so daily lessons, page 140. You should be really excited about this one when you see it because you get to use a calculator. Yay! So use it. Make sure that you know how to use it and make sure that you're trying to put these values in. Okay, a test plane flies in a straight line. Of course it does because our particles only move left and right. Our runners only move right and left or on a straight path. Our cars only go forward and backwards. So, really realistic. But a plane flies in a straight line. It has a positive velocity in miles per minute at time t minutes where v is differentiable function. As soon as you see this, v is differentiable, what else does that mean? Yeah, therefore, continuous. So these little blurbs at the top actually matter a whole lot. It will matter on tests and quizzes. Anytime you see something as differentiable, it's also continuous. It says selected values of v of t for 0 is less than or equal to t is less than or equal to 40 are shown in the table. So some of them are here, but I know that velocity is always positive. Okay, find the average acceleration. As soon as you see average, you should be thinking slope of the secant. It's always slope of the secant of whatever function is above it, whatever acceleration is the derivative of. In this case, velocity. So I'm going to say v of 20 minus v of 5 over 20 minus 5. V of 20, I'm just getting this from a graph, so 4.5 minus v of 5 is 9.2. So in this one I'm going to say 4.5 minus 9.2 over 15. And I can use my calculator, so I'm going to and figure out that this is negative 4.7 over 15, or approximately negative 0.313. Careful with this. In this one, you've got v of 20 minus v of 5. Velocity is given in miles per minute. 20 minus 5 is given in just minutes, miles per minute per minute. So I've got miles per minute squared. If you get the units wrong, your answer is wrong. Okay, express your answer using correct units. Oh, that they tell you that too. Based on the values in the table, at 1 intervals is the acceleration of the plane guaranteed to equal 0. Okay, guaranteed. As soon as you see that, you should be thinking, okay, what theorem is that on now? Acceleration. I'm given v. Acceleration, I know, is v prime of t. Think about it. When is v prime of t equal to 0? What theorem is talking about the derivative being equal to 0? You could have thought of two. Mean value theorem, you have to do a little bit more work. Or Rolle's theorem. Rolle's theorem, a function has to be differentiable. It has to, or first it has to be continuous, then it has to be differentiable. This one is. Remember? It's continuous, it's differentiable. But the other thing that has to be true is that f of a has to equal f of b. So if I'm doing this, I'm going to use justification first. So a of t is equal to v prime of t. And Rolle's theorem states for a function continuous and differentiable, as it was given, so I'm writing below continuous. This function v of t was differentiable, or is, doesn't matter. So it's continuous and differentiable, and f of a equals f of b. But in this case, and I'm going to say v of a equals v of b. But I want to be even more specific with that. So I'm going to go through and see, when does that actually happen? When is v of a equal to v of b? So I'm going to go through and I'm going to check. I can see at 7. So when this would happen would be at 0 and 15. So v of 0 equals v of 15. 9.2, if I go through, I don't don't see any other 9.2s. 9.5, I don't see other than 9.5. 4.5, nope. 2.4 and 2.4, yay, we have another winner. So 25 and 30. That also, f of a equals f of b, or in this case, v of a equals v of b, and then nowhere else. So, as at is equal to v prime t, and Rolle's theorem states for a function continuous, differentiable, and where the initial value equals the other one, this is asking me exactly, on what intervals is the acceleration in the plane? Acceleration equals 0 on the intervals 0 to 15 and 25 to 30. So we've got two different places where acceleration is guaranteed to be 0. In this one, okay, so I justified my answer, I showed all my work, and I'm running out of room, so I'm probably going to erase things soon. But does the data represent velocity values of the plane moving away from its point of origin or returning to its point of origin? Okay, right now I know in C it said v of t was always greater than 0. So if v of t is always greater than 0 from 0 to 40, that is representing moving away from its point of origin. So, don't erase yours, I'm going to erase mine. So for C, I would say, as it is given, v of t is greater than 0 for all values. 0 is less than t is less than 40. I'm going to say the plane is moving away from its point of origin. It's never going back. It started in one place, it continued to move in the same direction. Away. Okay, and the last one, the function f defined by this function is used to model the velocity of the plane in miles per minute. According to this model, what is the acceleration of the plane at t equals 23? And this one, it says calculator permitted. We're going to use that. So if this function is used to model velocity, and I want to find acceleration, what I'm going to do for part D is I'm going to find f prime of 23. So if I put in f prime of 23 into my calculator, I can get negative 0.407. Be careful about this though. We were talking about miles per minute before. This will be miles per minute, so per minute squared. And it's saying in this one, because this is the same thing as acceleration, by the way, at 23. What does this value indicate about the velocity at t equals 23? So in this one, I want to know if what is happening to velocity. Well, right now, the derivative of velocity tells us whether velocity is increasing or decreasing, right? So if this is negative, so as f prime of 23 is less than 0, velocity, v of t at t equals 23 minutes is decreasing. Notice it didn't say anything about speed. It doesn't ask me about speed, so I'm not checking the signs for velocity and acceleration. It's just asking me about velocity. So if I have the derivative of velocity is less than 0, that means that velocity itself is decreasing.